Hey guys, let's take a look at our homework tonight for 7.2, right? Okay, so the problems that we are supposed to be working on is 11, 12, 15, 16, 20 to 24, and 26 to 28. So let's attack. All right, in the diagram, so this one is my pre-image, right? In the diagram, they're saying, ooh, we didn't talk about this in class. That squiggle is somebody who's too lazy to say similar. That symbol means similar. Interesting. Okay. So they're saying this guy is similar to that guy because their angles are the same and their sides make the same ratio. That's what similar means. What are the angle measurements? Okay. So we know if a shape is similar, then the angles of ABC would correspond to A prime, B prime, C prime, and D prime would match up. Okay, so B is 80. That would make this 100. So that would mean B is 100 and B prime is 100. Make sense? Now, what else do we know? Let's see. This is an exterior angle. We know exterior angles, the two remote adds up to this exterior. So what is that? 125 take away 48. 77. Let me just double check my answer there. 11, 12. Okay. Yeah, so it looks like this is 77. And so that would make angle D 77. So that's 77. So since angle D is 77, then D prime would also be 77. Now we notice here that that's parallel, right? So if it makes a Z, that's AIAT. So that means this is 80, then this would also be 80. So this is not an isosceles trapezoid. So C is 80, so that would make C prime 80. Okay, last but not least, it is a four-sided shape. And we know that the sum of the interior angles have to follow this formula, 180 and minus 2. So it's a four-sided shape, which means they all have to add up to 360. So if I take 360 and I just subtract off each angle, 360 minus 80, I get 280, minus another 100, so subtract off that one, I get 180. And I subtract off 77, I get 301. Okay, so this angle has to be 103. So if angle A is 103, then angle A prime is 103, and we have answered the question, what are the angle measurements of A prime, B prime, C prime, and D prime? Cool. Next one. Number 12 says, are all squares similar? So we kind of already answered that in class, and you can Google it. If we move a shape and then we blow it up, then we recognize it should fit right on top. So our answer is yes, all squares are similar. Because the definition of similar is angles are the same. And we know those are all right angles, right? So the angles are the same, and the sides make the same ratio. So if the top corresponds here, maybe this is 1, or I'd say 2 units, and then this one maybe is 10 units. We could make a ratio there, 10 over 2. Now picking another side, this is also 2 and this is also 10. So picking another corresponding side, notice their sides make the same ratio. Their sides make a ratio of 5. So all squares are similar because their angles are the same and the sides make the same ratio every time. It said use a transformation to explain. So I actually showed I can translate, right? I scooted it over, like in my picture, and dilate. And it maps on top perfectly. Nice work. Now let's take a look at, okay, so that's all, number 15. Okay, so remember we got to do this one first, dilate. So that means we have to multiply every number by 1.5. So x would be 6 times 1.5. 2 times 1.5. 4 times 1.5, 1 times 1.5, and z, -2 times 1.5, 3 times 1.5. So 4.5. Okay, now we're going to do this second. So we're going to add 5 to all the y. So plus 5. 5. Ooh, no, just the x though, right? Add 5 to the x. And then we're gonna subtract 4 from all the y. And then this is z prime was 2. And subtract 4, so I get 0.5. Nice work. All right, what if we dilated and then rotated or reflected it off the, so we got to flip it over the x-axis. So let's see. First, we got to multiply everyone by 0.5. So half of 2 is 1. Half of 4 is 2. 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 Half of -4 is -2. Half of 2 is 1. Half of 2 is -2. Okay. Now we're going to flip it over the x-axis. Ooh, I didn't bring my notes home. So you could Google what that is, or you can actually make a quick sketch if you ever forget. So here's an example. If I had a point, 3, 2, and I flipped it over the x, it should make sense that now it is 3, -2. So the pattern is the x stays the same and the y changes sign when I reflect over the x-axis. So let's see. Our new coordinate, the x stays the same and our y changes signs. Beautiful. All right, there's my new coordinates. Oh, 17 I get to skip. 18, 19, skip, skip, skip. I love it. Well, let's take a look at 20. How do I get this to map upon itself? Let's look at our directions. Describe the similarity transfer motion and write a similarity statement. Okay, so there's multiple answers. But which one do I have to go? A to B or, yeah, I guess we can assume that this is my pre-image. They don't really say. So I'm going to scoot it over here if that's okay with everybody. So I'm going to translate it, right? Right for, and I didn't move it up and down. Okay, I did that first. Now I think I want to flip it over. So I want to flip it over. So now it's like here, I guess. Can't really see that. So that's reflect over. This is parallel to the y-axis, so that'd be x is equal to -5. All right. And then last, it looks like I want to double it. So, right? So this length has doubled. This length has doubled. So we want a dilation of a scale factor of 2. That is my combination of transformations. All right, now what about this one? And it looks like this is the shortest side and that's the shortest side. So I got to spin this thing around. I got to rotate this thing. So let's spin this bad boy around, and so then it would be facing, this is hard to do, but I feel like it would be facing here. Yeah. All right, so if I spun it around, now it's kind of oriented the same way. You kind of see that now. All right, so I want to rotate. The first thing I want to do is rotate 180 degrees, right? That's the first thing I want to do. And then I want to move it over and up. So I don't know, but translate it. I'm just gonna make up numbers here. I'm gonna say that's 10 to the right and up 2. Translate it 10 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 2. Great. And then now it's going to be laying just like right on top of there, right? So does that look about 2? It's not exactly 2, but we're going to just say, I want it bigger, so I'm going to pick dilate it 2. It's probably not exactly 2. Like, so for instance, it could be like 1.8 or 1.5. Okay. Let's take a look at 21. Are these similar? I'm going to say yes. And this one I'm going to say no. No way. Why? Well, again, if I scooted this one over and up and spun it, it would fit right inside. So see how this one would fit right inside there. And then if I blew it up, it would map on top of itself. So it would map on top of the other figure with a combination of translate and dilate. And so we know that that should work, right? A lot of other people said yes, and they just said more generically, they're the same size, just not the same, or excuse me, they're the same shape, but just not the same size. Now we have to be careful here with just that kind of a wording because these are both trapezoids, you see? And what's interesting is this length is equal to this length. So this is a shorter, or this is a taller version of this one. So it's been stretched out in the height, but it hasn't been stretched in the width. These two shapes have the same width. So when we blow things up, notice with a coordinate, like when we took the coordinate 8, 3, when I dilate, notice I double both of my coordinates, 16 and 6, not just one of my coordinates. So they're the same width, but it got taller. Yeah, that doesn't work. Okay, let's take a look at 24 and 26. So in a couple of the classes, we talked about 24, so this is good to talk about. And this is like our map question. So if I have a ratio, it looks like I can put a ratio length over width, right? And I just have to be consistent. Then that is 3/4 or the decimal 0.75. So when I do the same with 9 and 12, which happened in our example, that's equal. So we're good to go here. This one's good. But if we notice this one, 120 over 180 makes a different decimal. So this one's not similar. Now you might think though, maybe we could cut some of the width or cut some of the height or both to make it similar. Okay, now let's look at 26. Juanita wants to make a dollhouse following the pattern, but she wants to make it smaller, reducing the size so that the floor area is 25 inches. Make a sketch showing the dimension of the pieces for the smaller dollhouse. All right, so we know all squares are similar. So this floor, I want the floor, my new floor, I want to have an area 25, which means I want my new floor width to be 5, right? And the height or the length to be 5. 5 by 5. My old one, my old floor, is 6 by 6, right? Which means its area is 36. So its current width is 6. So my old times my scale factor is equal to my new. So if my old is 6, and I got my scale factor, and my new is 5, then I can use just some quick algebra to solve for what kind of scale factor would this be? 5, 6. So I want a scale factor of 5, 6. That means each dimension I'm going to multiply by 5, 6. Make a sketch showing the dimensions of the pieces for the smaller dollhouse. Oh, okay. So I have a side, a back, a roof, a front, a floor, and a side. So my floor is going to be 5 by 5, right? I've done that one. This floor matches this floor. Let's do the back here. Let me do that a slightly different color, right? My back. So 6 times 5 sixths is also 5, so that would be 5. 13 and a half times 5 over 6 is, let me just crunch that. It's 11.25. And we notice that same number, 13.5, comes up a couple different spots. So I'm going to do that same, stick that in those places. And again, kind of noticing anytime where I see the 6, I can put 5 and 5. So another dimension I need is this 9. 9 times my scale factor, 5 sixths. 9 times 5 divided by 6 is 7.5. So wherever I see the 9, I'm going to put 7.5. So wherever I put the 9, I'm going to put 7.5. And that's it. Cool. All right, most classes we did these last two, but I will talk your way through it in case you're absent. So it says here, we're going to rotate over x-axis, reflect over the x-axis, and our notes said that means x stays the same, but y changes sign. So if I took the coordinate 8, 2, the x stays the same, but the y goes from a positive 2 to a negative 2. Now I'm going to dilate a scale factor of 4. So that means I'm going to multiply each number by 4, and I get 32, and I get negative 8, which is how we found our answer D. Cool. All right, last one. Looking at Lourdes, she makes a sketch with her graphic novel, and it looks like she's making a lot of like a teardrop shape. She's turning little creatures into, turning these things into creatures from the same shape. She's repeating similar objects. So I want to make a clarification here. I call these mommies and babies. So these actually look like congruent shapes, but like we said today, similar shapes have the same angles, but the sides make the same ratios. So in this example on part A, it says, draw a simple figure and label it A. So that's what I did in class. I labeled this first figure A, and I just made kind of a lopsided Christmas tree. There it is, figure A. You can think of it as kind of an arrowhead. Then in part B, it says use similarity to create at least 5 inches and label them B, C, D, E, and F. And they need to be similar. So let's see. B I made from just shrinking. C I made from shrinking and then turning 90 degrees clockwise. E I made by shrinking and then turning a little bit counterclockwise. And D I made pretty close to the same shape. I just flipped it upside down, right? Oh, it said I needed an F. Okay, I need one more. Let's do it. So I guess I'll just point it this direction. There we go. Figure F. Now it says part C, is it possible to select any 2 figures of similarity and map on top of the other one? And the answer is yes. Similar figures will map upon one another after you do combinations of transformations. So what do I mean by combinations of transformations? As I said, I flipped it over and scooted it down. Or I shrunk it. Or I shrunk it and I spun it, right? Nice work, guys.